Here you can see our database is stopped status. Why? Because I don't see any files here. I don't see any services here. What you can do, just execute the HDB space start. You should know about how to start the HANA databases, how to stop the HANA databases. All those things also you should be required here, right? So then so it will be starting now. It is starting now. So while starting, you know what will happen, right? While starting, we know what will happen here. So while starting the system, so here it will load the all the data into main memory. Into main memory, it will load the all the data into main memory. It will perform it here, right? So it will load the data here. So that is what it is loading the data. That's why immediately HANA will not be started here. Immediately HANA will not be started due to loading of the data here. So here nothing is in our hand loading of the data here. Why? Because based upon the system speed, the processor system speed, so the multiple process will load the data here. Multiple process will start loading the data, all those things here, right? So now you see it's loading slowly, slowly. So it is loading, but we can observe it. So the loading option, we can see what are the tables still loading or not. We can observe it in the index server dot log file. Index server log file, we can store it here. Index server log file, we can store it here. Okay. So once it is started, it is not in the source file. Incident will be reported or something is happened. TCP video. So this Linux commands are really very, very important actually. Switching the user. So those things are very, very important. So here you can see, so HD1 I'm starting. Might be systemdb will start very soon because so systemdb, there is no data. So it will start, it's a very soon here. But the only thing is here, the tenant DB only will take the very longer duration here. Tenant DB will only take the so longer duration. Why? Because index server. So all the data will to be loaded first, then it will start it here. See here it is starting now. I think it started. You can see. So you can connect it to the everybody. We can connect to the HD1 instance number 00. HD1 instance number 00. You can use it here, right? So then I'm just using the our same passwords I am using. I have connected to the tenant also. Tenant also I have connected here, right? I have connected to the tenant also here. So now you see here databases we started, we have connected here, right? We are able to connect successfully here. Now you see, so here we have the catalog, right? So you can see the other folders in the system here called the catalog here. Backup is for the backup checking. When was the last backup completed? All those things we can check it out using this backups. This backup we can use it here. But you see here catalog option here. Catalog is for the, so normally in the database level, what will be there? Data. Where? In the table. Where the tables are available? Under the catalog. So here under the catalog, we have the schemas. Under the catalog, we have the schemas here. So under the schema, we have the tables. Under the schema, we have the tables are available here. So first catalog. Under the catalog, so we have the schema. Schema is owner of the tables. Then we have the tables are available. Inside of the table, we have the data, right? So if you want to see the tables data, where you have to go? Have to go to the catalog and the respective schemas, catalog, and you have to go to the respective schemas. These all are the schemas here. Schema means the owner of the table. Schema means owner of the tables here. Owner of the tables, we will call it as the schemas here. Schema. Owner of the table, we will call it as the schemas here. Why? Because suppose like if you take the, so company, in the company means database. Within the company, we have the number of teams are available, right? IT team, HR team, above team, basis team. Each team, we have the one lead, one manager, right? Under this manager, all the members are available. Same as like here also, here we have the owner. Manager means owner of the respective basis team or respective above team. Here also owner. These all are the owners here. So you can see any one of the, just if you open the any one of the, just expand it here, any one of them, then you see the tables here. If you see the tables list here, if you see the tables list here, each table, we have the number of, each schema, we have the number of tables are available. These all are the tables here. These all are the tables here. Number of tables are available, which created by the system, during the installation time. These tables are created here. These tables are created. So if you view the data, right click, and if you view the data preview, you will see the data, the tables data. You can see it here. You can see 1,000 rows retrieved in the 364 milliseconds. If you execute again, 75 milliseconds. If you execute it here, so based upon the system speed and performance, you can see it is reducing. The minutes are getting reduced here. Milliseconds are getting reduced here. Why? Because it's a speed. HANA is on fly. We can perform the table analysis. So this much of analysis we cannot perform any other databases here. Fraction of milliseconds we can perform the table analysis here. Not only viewing the tables data here, not only viewing the tables data, and also we can also go to the analysis of the table. So there we can perform the analysis here. There we can perform the analysis here. Analysis means just to, sir, what is this column description? In the graphically, we can see the analysis, right? Within the database itself, just we can provide the table names. In the x-axis this one, y-axis this one, like this we can provide it. Then we can perform the table analysis, graphs analysis. So which chart you want? You want to pie charts, you want to line chart, which chart wise you want to do the analysis here, which chart wise you want to do the analysis wise here. Normally graphical, if you want to line chart, bar charts, so whatever the charts you want to, if you want to line charts, so line chart wise we can see it here. So this wise 3D charts wise, we can see the table analysis. These all are one table analysis. This is the, see here, fraction of seconds, just we have prepared the analysis also, right? Fraction of seconds, we have prepared the analysis also. No one. So we don't need to, normally previously we need to export the table data, content data, then go to the Excel, then export it, do the Excel work, may take very longer time. But nowadays, not required in the HANA database. So just right click and preview the data preview. Right click any data preview, not only this one, any date table, just data preview, the data will be showed here. Raw data means real data, real time data will be showed here. The data will be showed here. These are the fields. These are the fields, and these all are the, so in the fields we have the data here. These fields we have the data here. These all are the data are available here. These all are the data and the fields, columns, and rows are available here, right? It's available. All those details are available here. I want to do the some kind of graphical analysis. Normally salespersons, when they are trying to release the one product into the market, what they will do? They will do the they will do the marketing. They will do the first of all analysis. If they are trying to release the one product into the market, so they will check the trends. How was the previous year's trends? In which dated, in which month they have the huge sales. So then in this case, the sales data, everything is available in one of the tables, right? Then they will right click on the table. They will see that they will go for the analysis here. So in x-axis, what you required, then y-axis, what you required, like that they will fill the data. Like that they will they will scale out the other fields. Then so they will scale out the other fields and they will see the all other things they will perform it here strings. So they will perform it the all other things they will perform it so that the graphically the data will be displayed. In this way they can find out, oh, so trends. So in which date it is very high sales. So during this date, during this month, they will release their product into the market. So that's why they will business owners, they will take the decisions based upon this one they will make the business decisions. So here HANA not only storing the data, and also we discussed during the starting time, so within fraction of milliseconds we can perform the table analysis. Within the fraction of milliseconds we can perform the table analysis of the tables here. So that's possible here. And also, if you see here, if you right click on the table, so here we will get the more options here. If you want to delete the table, we can delete it. If you want to import, if you want to export and imports, whatever you want, you can do it here. Table level, we can do the tables here. Suppose if you want to create the new table, suppose you want to create the new table here. So you can also create the new table here. You can also here also we can create the just create the new table we can create it here. Suppose like I want to create the some training table. So Z training table. In the training table, the first one is like so name of the student. Then so batch timings here. So then so all the whether is present or not, like that I will fill it. I will fill the some data here. Like that I can also create the some table here. You can see some table. We can also manually create the tables also here. See a Z training here. Then if I just view the data preview, once I fill the all the details, then I will get the list of all your names here, all your timelines here. Then whether you are practicing absent or not, then if I maintain the one track history here, so then we will get the more data here. The data will be displayed here. So the application side, I can create one application or one app. I can create it. That app I can just provide this database name and this table name. If I link it, then the data will come and insert into the DB level. DB level it will be inserted. Just I will do the entry in the application level, application either mobile app and the URL. Then the data will be available here. So all the rows and everything will be inserted here, right? Here, not only this one, suppose if we want to, so load this table into the memory. Suppose we want to load this table into the memory here. So you want to load this table into memory. Suppose like example, this table performance is very bad, very huge size. So, but you want to unload from the main memory. If you unload from the main memory, the usage will be reduced, right? The DB usage will be reduced because of if the table is in the main memory, it license also it will occupy it, and also there is a the performance improvement also. If the table in the main memory, within quickly we can get the table results quickly we can get the results from the table, we can do it. So that is in the main memory. But if the table in the disk storage, it may take some time to give the results to us, right? So that's why whether it's your decision, if you want to make the table load into the main memory for the better performance perspective. So see here, whenever you want to load it, then complete table including the delta storage into the main storage, right? So this is the size depending upon the size. Just if you click it out, so that table will be loaded to the main memory. Suppose if you want to unload from the main memory, unload means, so the action unloads the table including the delta storage from the main memory. It is accessed very slowly, the slower, because of data will have to reloaded to main memory means, so it will be available in the disk level. So whenever you are accessing the next time, first it will load the data into disk to main memory. That is what the delta merge concept we discussed, right? So this is the HANA, this is the RAM slot, main memory and everything. Then this is the disk storage slash HANA data and everything is available, all right? Slash HANA data, then slash HANA, then log folder, here it is available here. This is the disk storage and the main storage here, disk storage and main storage is available here. DS and MS is available here. So whenever the table is available, normally the data will be stored here, right? Actual data and everything, whatever stored, it will store into data into the main memory itself only. This is a disk storage. So if you want to load the data, then data will be loaded from here to here. So it will be very fast. If you want to unload it, then table will be unloaded from here to here. It will come to the here. So table is not available here. So if you want to access the table, what it will do? Oh, first table, it will check here, it is not available. Then it will go to the disk level, it will search it out and it will pull the data here. It will give the results to the response. Oh, lot of things here. There is a delay, right? So that's the reason they are saying that there might be a performance impact here. There is a may take the some time to here. Then we can unload it, load it, we can unload it. That is also possible. But it's not the, so we can, based upon the situation, we can take the decision. One more thing is you can see it here, delta merge, perform the delta merge. Now you know what is meant by delta merge. Sometimes what happens, so the data, the changes will not be reflected into the system. Even though you moved one transport, but changes are not reflecting. Two transports, changes are not reflecting. So then you suspect like there is a issue or something, then you will start investigating whether the changes are moved or not. Sometimes what happens, due to deadlocks or due to some other backups or something, you say the changes will not be visible here. The changes will not be visible. So for that reason, we can perform the manual merge here. You can see merge, commit the entries from delta storage to main storage. So merge means here whatever the entries are there here in the DS, all the entries will be merged to the main storage here. The transactions, queries, everything will be executed here. Once the transaction is committed, the data will be moved to the main storage. But sometimes what happens, due to the operation issues, it will not merged here into the main storage level. Then in this case, so we can also perform the manual merge here. There are the types of merges are there here. Types of merges here. So normally application will take care of that one. That is called the smart merge. Smart merge here. So then force merge, which we are merging manually, that is called the force merge. So then sometimes, so smart merge, force merge, there is a system depending upon the hard merge. Then so there are some other one or two types are there. So depending, smart merge means which application will detect, means application will do that one. SAP application, that is called the smartly, it will merge it. Force merge, we are forcefully merging it out. So hard merge, so depending upon the issue, system automatically sometimes it will issue the hard merge. So then forcefully, so it will flush the data, it will move the data to the your so main storage here. Depends upon the situation. Normally this operation also we will not perform anything here. This is also will be taken care by the system itself only. How the delta merge save points are happening, this is also it will be taken care by the system itself. We will never perform any manual merges in the system. Automatically will be performed by the systems. We don't need any intervention here. So, and also you can see sometimes we can also perform. So sometimes you see the systems here. So the partitions here. You can create the table, export, import. There are many things are there. So sometimes we may have to perform the partitions here. So what is mean by partitions in HANA database here? So partition, okay, partitions here. HANA partition. Normally partition means in our home, normally in a 2 BHK flat, we will partition into the one master bedroom, one small bedroom, kitchen, or like that, how we will do the partitions, right? Same way, so as per SAP recommendation, if the table size is, if the table space is more, as per SAP recommendation, if the table size is more, means more number of entries in the table records, then SAP recommended to go with the partition. So means if the we can split the column store tables, larger tables into smaller tables. In a partition, we can move to the smaller tables. We can divide the tables into smaller and more manageable parts using the partition. Okay. So normally we have to use the queries or system internal options. We can use it here. So normally every table there is a limit, 2 billion 2 billion records, 2 billion records here. So if the table count is the table entries is a more than 2 billion records, then we can go for the partitioning. We can go for the partitioning here. When a table is partitioned, then the set of rows, the rows of each partition can be done using the different algorithms, different partition methods. So you can use it means whenever suppose we have the 4 billion records. If you partitioning into the two partitioning, then 2 plus 2, 2 billions plus 2 billions wise, the two partitions wise, the records will be distributed equally. In the HANA, we have the partitions concept. So what will happen? One table more than 2 billion record, the performance will be very slow, right? Suppose example, so you see this is the one of the table in the HANA database, right? This is the one of the table in the HANA database here. So rows and columns we have here. So this is one of the employee table here. There the so 5 lakhs, 5 billions or 4 billions records are there, means 4 billion employees related data is there here, 4 billion, 4 billion. So what will happen here? So one of the application or due to some analysis purpose or while inserting the table, so one person he queried, he needs some data from the data means 4 billion records. So it will search one by one, 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 one by one. It will search it out. Then it will take some time. Then grab the data from the table level. Then it will give the information back to the user. So it is taking some time. Why? Because 4 billion records into the one table itself only. So one partition, one table. Suppose if you split this 4 billion into 2 billion in one table, same table, 2 billion, one partition, the same table in the one more partition. If you do it, one more partition, if you do it, so if you do it here, there are the 2 billion records here, 2 billion records here. So if you split it, partition means splitting the even larger tables. It's a more than 2 billion records tables into the smaller chunks here. So splitting into the smaller chunks here. In this case, what will happen here? In this case, what will happen? We are splitting. We are splitting here. We are splitting into the smaller chunks here. So that is the reason, we can use this partitions concept here. So that if the same query, that the same table is partitioned 2 billion records, what will happen? One thread will go and check here, one more thread will go and check in here. Then which thread got the quicker results? Then immediately records will be displayed to the user. 4 billions into the one record getting that time, and 2 plus 2, two partitions may take the, immediately they will get the response here. That is called the partitions here. So if the partitions, they are the different approaches we have. So total, they are the three types of partitions we have in the, currently as of now in the HANA, we have the three types of partitions here. Three types of, what depends upon the, so method, algorithms, you can use the three partitions here. One is the hash partition. Normally everybody will use the hash partitioning here. Then the next one is called the hash partitioning. Then next called the round robin. Then the third one is called the single row, single level partitioning here. One is the, so hash partitioning, so multi-level partitioning. Where the types are there, hash, round robin. So then, so there is a one more partitioning actually, single hash, round robin, and there is a one more partition. Let me search here. Range partitioning, yes, value based partitioning, range, yes, right, range. So range partitioning here. So there are three types of partitioning are there here. So here, so hash partitioning means, so equally distributing the table, distributing the entries here, equally distributing the entries here. So equally distributing the entries. Suppose if you see the HANA Studio here, so just suppose you want to do the partitioning of this table, right? So here, right click on the table, there is a partition the table here, partition the table here. You can see hash partitioning and round robin and range partitioning. Hash partitioning. Hash partitioning means here, so suppose one of the table entry, it has more than 2 billion records, then you can equally distribute number of partitions, 3 or 4, you can distribute it here, right? So that what will happen, so what is the primary field here? Name is the primary column here, select it. Then you can choose it, the partitioning is done. So number of partitions are 2. Here we won't get to, we don't have much records, but here is partitioned into the, so 2. One here in the one partition previously we had a maximum size, number of records, all those things are there. Here the number of records which are coming to the inside of the system, then it equally distributed into the one partition and another partition. Like this, it will distribute it here. It equally, it will distribute it here. That is called the, so hash partitioning. Hash partitioning. So same one of the one, once the table is partitioned, we can also partition into the multiple repartition. I mean to say, we can also do the repartition also here. Repartition also we can perform it here. That is called the size limitation is 2 billion records. 2 billion records we can use it here, right? So hash partitioning means equally distributing the records equally to perform the load balancing activities here. So here we don't require detailed information of the table count, table content, partitioning type, everything. So as compared to the hash partitioning, the round robin partitioning are the, each partition wise new rows are equally distributed. Not only existing one, the new rows also equally distributed to the existing partition. So suppose if you see here, when you are doing the partitioning here, it's our choice based upon the content here. We can do the partition. We can do the partitions here based upon the, so we can partition it here. So this is already partitioned. Then I reverted back to the previous status here. Means we can unpartition also we can do it. Then we can do the partition. Then here hash partition is there. If you use the round robin partitioning here, round robin partitioning here. So hash partition is equally distributing the load means rows, means load balancing purpose. So you are the, suppose if you choose the multiple partitions, two or three, equally it will distribute to the all the loads here. Table records will be split into the three or four, whatever you choose it here. But if you compare it to the, suppose if you take the round robin, if you take the round robin, in the round robin, if you take the round robin, in the round robin, the partitioning rows are equally distributed to each partition, as well as new rows are equally assigned to the each partition. So not only existing rows, new data which is coming, new data which is coming. Suppose if to create the four partition table, we can use the round robin methods, that's fine. But tomorrow, if the new entry is coming A and B, then the A go to the first row and B coming to the second row. Like this, it will go to the, so it will go to the round robin algorithm anta. So then means round robin base, the columns will go to the, suppose like two partitions. Then equally it will be distributed. Equally means first record will go to the here, second record will go to the here, third record will go to the here, fourth record will go to the here, then fifth, sixth, seventh, like this. So equally the new records will be inserted into the serial wise, it will be inserted here. Serial wise, it will be inserted here. That is called the, so round robin method, round robin method here, round robin method here. So round robin wise. So if you take the range partition, you create the dedicated partition based upon the values here. So range partition is for the values, value based partitioning here, values. So you have to give the values here, create the one partition for one calendar. Range value based here, this is the value based here. Maybe BW, distributed environment, we need to give the values here. It's required the more in-depth knowledge, the contents, partitioned columns. So based upon the certain values, we should have the, so some in-depth knowledge we have to give it here, right? So if you could suppose this will also, we can create the four partitions. Suppose example, this will also will create the four partitions. One partition range is for the 1 to 10. Second is the 10 to 20. Third is like 50. Fourth for all other values here. In this case, so values, the range of the value, if you have to give the values here, then only based upon the value, based upon the values, suppose like partition 1, start value, end value. We can just add the values here. So start value 1, 2. So suppose like start value, end value, only 10 rows here. Then, so like this, we can insert the rows here. The values based, the first to 10 records will be stored here. Then 11th to different partition. Like this also means however you want to do the entries, the numbers, you want to the records in the table want to partition it. So based upon the your custom requirement, we can choose this one. Otherwise, normally everybody, this is the recommended partitioning, hash partitioning. So as per this one, it's not required more in-depth knowledge here. So it's not required more, so more knowledge, everything. Same as like range partitioning. Range partitioning is the very critical partitioning. It's required the some in-depth knowledge of the table contents. What are the contents are there in the table, partitioning columns, all those things you required here. Otherwise, we may face the lot of issues there from there here. So that's why, we require the, so hash partitioning is the very good one here. Hash partitioning is the very good for, so do the partitioning of the systems and everything here. Or so round robin also fine. But if you want to go for the range partitioning, we have to specify the values here. So in the based upon the table count, so based upon the table count, fields level means you need some table level, how many records, the record structure looks like. all those things you required, all those things you required here. So that's the thing here we will require. That is the thing here we will require here, right? So that is the partitioning. So three types of partitioning. So it depends whatever the partitioning you want to use it here. So you can use the that much of partitioning range 1 to 10. So first 10 records here, next 10 like this, it will store it here. Sometimes we may face the performance issue also. Why? Because so directly the call will come and do hit on the here itself. If you don't have the in-depth knowledge, we may face the some issues also here. So that's why. So this is a very dangerous like a range partitioning. I mean, they not dangerous means it require the some in-depth knowledge here. But some other partitioning, you don't require much knowledge here. Much knowledge is not required. Directly you can
And so partitioning we can do only in a table. Am I
yeah,
right?
yeah, table level, not the schema level, especially only one table. So if you want to do the partitioning of the any table, what you have to do, you need to go to the schema. First of all, you need to check the schema, which schema and what is the table. Suppose like this is the table. Right click, not like here, right click on the table, show table distribution. So table distribution. Suppose you want to go for the system, right click and show the table distribution here. Then here you will get the list of tables. But this is the standard table, so nothing is showing custom tables here. Here, if you go to the here, then show table distribution. Here you will see the one table. Right click on the table. Then right click on the table. You can see the partitioning. Just you will get the part. Right click
Sir,
on the.
what is the difference between custom and those sys table?
So custom these okay. Here tables also we have the two types of tables. One is the SAP standard tables, which will come as part of the installation. Did you create all these tables? No, right? A, B, C, D, F, P. So there are a lot of tables up to Z. We have the tables are available. These are the SAP standard tables come from as part of the SAP installation to store the SAP related data only. So these are the custom tables means which we create, user create. Suppose like you are starting the training business. Then you created the one app to store the all the training records and everything from the thing. Then you are creating the food business. Then you can create the one table for the food. So food items. So then, so you can store the all the entries here. What is the food name? So food one, food name, like so something like that. You can fill the data and all those things. So that if you create the one table, what will happen? So if you order the food, the data will come and insert into the in this food table here. So one day fine, 2 days fine. If the food business is more, right, number of orders you will get means number of records will be table size, number of records will be more in the table level. So 1 month, okay, 2 months, okay, third month is okay. Then 1 year, then lot of food orders will be stored into the in this food table itself only. Then, so if you delete the table, so then history will be gone. All users, there is a history will be gone. Who booked and last time and everything, all will be gone. That is the very dangerous, right? So that's the reason. So to get that one, we need to maintain the data into the table level, database table level. We have to maintain the table level here. So if you do the partitioning, so what will if you the suppose like 5 billion orders are there in this food table. You want to one of the user complained or you want to check the in the month of January 25th, 26th, how many orders are there? You want to just estimation, you want to check. Then in this case, you will write the query application level, you will search it out, it will go and come into the pull the table level, it will grab the data. But table records are more, it will take time. If the table records are very less, then it will be very speed. So if the table records are very more, then how can I improve my system performance? By doing the partitioning of the table. Just you can partition the table. You have 5 billion records, what you can do, so 5 billion records, right? Then you can equally split it, the 5 billion records into the, so maybe 2 means 2.5, 2.55. So more than 2. Then I can go for the 4, 2, 4, 8. Then 2, 4 means 4 partitions, 5 billion records, 5 by 4. Maybe 1 point will come, right? then that's fine. Then you can go for the partitioning here. So food name. So then the records will be partitioned into the four partitions here. The first two set of 1.5 here, 1.5 here, 1.5 here, 1.5 here. So like this, so the records will be stored into the here. So then any request coming, then it will search, okay, four partitions, then four threads will be initiated. Then immediately it will pull the data, it will give the response to the your app, your application, user front end will give the results. That's
So
why,
is this online activity, sir?
yeah, it's online activity, but better to perform the stop the SAP application and do it in the offline itself. Means the database is online, but application you need to stop it. Otherwise, we may, why? Because this will take very longer hours. Splitting the, okay, one or two records, fine. So 1 billion is okay. If the 5 billion records splitting into the online means, so if the new records are coming, there is a deadlock, then there is a memory issue. You have the system issues, you may face a lot of things. Better you stop the SAP system, so then do the partitioning, it will be complete very soon. But because this is a food table, right? So if you don't perform it in the offline, what will happen? Other side, while performing the this partitioning, it will lock the table entries. It will lock the table. It will lock the table. Means none of the records will be inserted into this table. So what will happen? The users cannot book any orders, right? They cannot book the any recipients, any food items. They cannot book it out. Why? Because the table is full. The table is busy now. So there is a lock will be happened. He has to wait. Means he has to wait. Then he will go, he will physically walk to the some other place, or he will go to the some other site. Then he will book the food. Right? He is missing that order. Then there is a loss. Right? That is the reason they will perform it in the off business hours, or they will stop the SAP. Like this, they will do it in the off business hours. Table record means if the system is go live, suppose our training and food item, not sure how many members will open the food delivery apps, they will book the orders. But each and every app, they will come to the call here in the this database, HANA database, they will insert the records here. Lot of entries will be inserted here. So table sizes keep on growing, 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 growing. Then
Partitioning, we need to take on a downtime.
yeah, yeah, it's a small partitioning, fine, but it's a number of records are there. Definitely, SAP system should be stopped, not the HANA system. SAP I'm talking about. So suppose
SAP
SAP,
MMC, that means
yeah,
from SAP
SAP,
MMC.
yeah, SAP should be stopped status. Otherwise, what will happen? You may face some performance issues. We faced it. That's why, based upon the experience, I'm telling. So better to stop the SAP application. Otherwise, while SAP on, small number of partitions we can do it. So, but it's more records. 10 billion records are there. Then you want to size also very 50 GB size or 200 GB. So say size of the table. Then it's very big activity. Then so better to stop it and do the activity. Okay. So this is about the catalog here.
And this partition we can perform in the system DB, not in tenant.
Tenant only, we have to perform. System DB, there
Tenant
is
only.
no data.
Okay.
Yeah, system DB, there is no
Okay.
data, right? Even
Okay.
system DB,
Okay.
there is no data here. Tenant only main here. Tenant means tenant, we have the index server. Index server is the one of the process. It will store the all the data in the form of tables. So tenant only we have to perform. System DB, why? There is no data in the system DB. So just only tenant only we have to perform all these activities. SAP applications or any applications will connect to only tenant itself only, not the system DB. System DB is only for monitoring the tenants and to do the administration part of the tenants via the system DB. Just only it will check the my tenants are okay or not. That's it. So then actual data will resides into this in this fields only. This way, normally table creations and everything, the development they will take care of that one. You don't need to worry. But just for example, I am explaining here. So what they will do, they will create the entry here. So one of the they will build the application, small application or URL. Just they will build the one of the interface here, user interface, either Swiggy, food delivery app or something like that. They will build it. So then you have the apps and everything. Then as Swiggy delivery application, right? Definitely there is a backend, there is a database here. Backend, there is a database here. Definitely it will store the data, all the data and everything. So we cannot directly interact with the DB, right? We cannot directly interact with the DB here, DB table. So why? Because if you directly interact with the table, you don't know what to write and everything, right? But application can interact with the table. So humans means we as a persons, we can log into the Swiggy, Swiggy, Swiggy. Then we can book the orders here. Number of orders we will book it out. Then the data will be inserted into the table level, the data will be inserted into the table level for reference purpose or future reference purpose. The business data will be stored into the here. Whenever you require, application will come and pull the data and it will display to the users. So while application is on, you are partitioning the table means some certain performance issues we may face it. Why? Because while table is partitioning, the table will be locked, means no data insertion possible. If no data insertion is not happening, then application how they can save the, how they can book the orders here, it will be failed sometimes, right? So that time, so we need to first of all stop the transactions. First of all means stop the SAP application, Swiggy, whatever it may be. Then it does quickly perform the partitioning, quickly perform the partitioning during the off business hour. Then bring up the then start the SAP application. Like that, we will perform the maintenance activities in the systems. Okay. So that is it. Yeah, you can just do the partitioning and other activities, SAP side activities. You can practice it.
హలో
Hello.
సార్ యాక్చువల్లీ ఎస్టర్డే మీరు టెనెంట్ డేటాబేస్ సింగిల్ డేటా అంటే ఓన్లీ టెనెంట్ డేటాబేస్ స్టాప్ చేయడానికి చెప్పారు కదా సార్. స్టూడియో ప్రకారంగా ఎస్క్యూఎల్ కన్సోల్లో చేసాం. అది ఓఎస్ లెవెల్లోనే సార్ మెయిన్ డేటాబేస్లో మనం లాగిన్ అయితే మెయిన్ డేటాబేస్ కూడా స్టార్ట్